It has been known for decades now that the universe's rate of expansion is increasing over time, but the exact cause of this effect is still unknown. Accepting the idea of the Big Bang, it makes sense that the universe is expanding, but logic would dictate that gravity should be trying to pull everything back together, meaning the expansion should be slowing over time. The most common explanation of this discrepancy is that there may be an unknown form of energy that permeates the entire universe that could be counteracting the force of gravity and causing everything to move apart faster. But how would you study this strange invisible energy that only interacts over extremely large distance scales? Well, that's where this comes in. This is Euclid. Named after the ancient Greek mathematician, this van-sized space telescope aims to do just that. Using its main instrument, the NISP, Euclid can take detailed looks at distant galaxies using infrared light, which will reveal how redshifted light coming off them is. This is useful, as the expansion of space is what's causing this redshift. So by measuring how much redshift there is, we can make detailed inferences about how dark energy works. This exact same technique was how the expansion of the universe was observed in the first place. But with its 65 million pixels of resolution, Euclid will be able to do this with far more precision than has ever been done before. The other instrument on board, called the VIS, is a camera that will observe light in the visible range in order to look for signs of gravitational lensing, which is the distortion of light due to large objects in the way, which may allow us to make more detailed observations of how much of a galaxy is made up of dark matter, which is the similarly mysterious form of matter that seems to make up around 85% of all matter in the universe, but is completely invisible to us. The housing of the spacecraft, known as the bus, is covered in solar panels for power and insulation to ensure the instruments inside are operating at the correct temperature. The rocket containing Euclid launched successfully on July 1st, 2023, and after a flight time of just 30 days, fell into orbit around a spot known as Lagrange Point 2, or L2. This is a specific spot where, due to the gravity of the Sun and the Earth, bodies can orbit stably, and since L2 is on the far side of Earth from the Sun, Euclid's shielding allows it to block out all the light from both the Sun and the Earth, and look out into the unobstructed darkness beyond. This is also why the Gaia spacecraft and the James Webb Space Telescope are also currently orbiting around L2. It's up there right now, taking data which it's beaming back to Earth at a rate of 85 megabits per second. If all goes to plan, this Dark Universe Explorer will remain in full operation for 6 years, by which time it will have completed the largest cosmological survey ever conducted in the visible and near infrared, and hopefully change our understanding of the universe as much as its precursor, the Planck satellite, did. Thanks for watching.